So this video looks at solving simultaneous equations with three variables using Gaussian elimination. So our first step is to set up our matrices. So our coefficient matrix is 2, 1, -1 for our first equation, 1, -2, 3 for our second equation, and 3, 5, -1 for our third equation. Our coefficient matrix is x, y, and z. And our constant matrix is 2, 7, and 0. So the best part about Gaussian elimination is we can solve this without using our calculators, which is what we've had to do before using our inverse matrices. Now our aim, we want that identity matrix on the left-hand side. So our solution will be on the right-hand side. So now we need to set up our augmented matrix. So on the left-hand side, we have our coefficient matrix. And on the right-hand side, we have our constant matrix. So we're combining matrix A and B. So we're going to start with the bottom left-hand element, and our aim is to get that to equal 0. So look at our other two rows, and you can see that in row 2 we have a 1 there. So if we go row 3 minus 3 lots of row 2, we will get that 0. So when we write our matrix, we know that row 1 and row 2 stay the same. And we're going to work with row 3. So 3 lots of 3 lots of 1 is 0. 5 take 3 lots of -2 is 5 take -6, which is 5 plus 6, so that's 11. -1 minus 3 lots of 3, so -1 minus 9 is -10. So now we have 0 take 3 lots of 7, so that's -21. Now our next step is we're going to have to make this one here 0. I can't keep playing with my third row because I'll get rid of this 0 here. So first of all, I need to make the second row that 0, so then I can start playing some more. So to make that into a 0, I need to look at row 1. So 1 here, 2 here. So if I go 2 lots of row 2 minus row 1, that will give me my 0. So my first and third rows are staying the same. I'm only looking at my second row. So 2 lots of 1 minus 2 is 0. 2 lots of -2, -4, -4 minus 1, -5. 2 lots of 3 minus -1. So 6 take -1 is 6 plus 1, which is 7. 2 times 7 is 14. 14 minus 2 is 12. Now I have the two zeros, I can now work on this 11 to make it 0. I can only use row 2 because it has 0 in the first element there. So if I look at how to make this 11 into 0, I'm going to have to go 5 lots of row 3 plus 11 lots of row 2. Think about it. You have to times that 11 by 5, which will give it 55. And then I'm going to add 11 times 5, which is -55. So it's kind of like if you're thinking about cross multiplying. So our first and second rows are going to stay the same. Now, if it's easier, you could do this in 2 steps. You could go your 5 lots of row 3 first and then worry about doing the next step in terms of adding the 11 lots of row 2. So if this is too complicated, break it up and do it in 2 steps. Right, so we have Our first element's going to stay the same because you're looking at 2 lots of zeros. 5 lots of 11, 55. 55 minus 5 times 11 is 55 minus 55. That gives us our 0. 5 lots of negative 10. And if you need to, off to the side, go negative 50. Plus 11 lots of 7 is plus 77. So that's 27. So now I have 5 lots of negative 21 plus 11 lots of 12. That's 27. If you need to, do the calculations off to the side. Now I need to make that 27 into 1. So I can just times my row 3 by 1 over 27. So my first and second rows remain the same. And I'm timesing by 1 over 27, or same thing, dividing by 27. Now move up into our second row, and we need to make that 7 into 0. The easiest row to work with is row 3. We can just go row 2 minus 7 lots of row 3. So our first and third rows are staying the same. We've got 0, 0, so that can stay. Negative 5 will be the same because negative 5 minus 7 lots of 0, 0. 7 minus 7 lots of 1 is 0. 12 minus 7 lots of 1, 12 minus 7 is 5. Now we can multiply our second row by negative 1 over 5 to make that negative 5 into 1. So our first and third rows are staying the same. Negative 5 times negative 1 over 5 is 1. 5 times the negative 1 over 5 is negative 1. Now we only need to play with our first row. Another thing to note is our solutions are coming out here. So from here, this up here, I know that z is equal to 1. Here, I know y is equal to negative 1. So now we only need to play with our first row. So in my first row, I need that 1 there to be 0. And I can do that by just going row 1 minus row 2. So our second and third rows stay the same. 2 minus 0 is 2. 1 minus 1 is 0. Negative 1 minus 0 is negative 1. 2 take negative 1 is 2 plus 1, so that's 3. And now work to get the other 0. And when you look at your third row, you can see that I could just go row 1 plus row 3. So our second and third rows are staying the same. Row 1 plus row 3, 2 plus 0, 0, 0 plus 0, 0, negative 1 plus 1 is 0, 3 plus 1 is 4. Last step, need that 1. So that's just going to be row 1 times by 1 over 2. Second and third rows stay the same. 2 times a half is 1, 0, 0. 4 times a half is 2. So therefore, solution is x equals 2, y equals negative 1, and z equals 1. And remember to verify your solution by substituting into your original equations. So I'm just going to do 1, you can do the rest. So if I've got 2x plus y minus z equals 2, my left-hand side is going to be 2 lots of 2 minus 1 minus 1. 4 take 1 is 2, which equals my right-hand side. And you just go through and check each equation. So the last example, solve the following pairs of simultaneous equations using Gaussian elimination. I want you to do this on your own, and then you can watch the next video to see whether your solution is correct.